A very good day to all the students. My name is Einstein Pillai Sankaran. Today's lesson is about organic chemistry, Alkane. This lesson is prepared for those who are taking chemistry in 0620 or 0654 coordinated science, IGCSE. So for those who are new in my lesson today, please watch the lesson that have been prepared earlier so that it will be helpful for you. So today we are learning Alkane. This is my first lesson for this. So in the previous lesson, we had some activities that was given to you to continue. So today I will discuss the answer for those activities and move on with the new things. So previously given for you to remember how to name or use whatever you have learned about the prefixes in organic chemistry and write the name for alkane, alkene, and alcohol. So guys, if you have done that, it is good. If not, take out a piece of paper and try to do this. It will be helpful for you and you would use it. So I'll be showing in the whiteboard behind here how to name alkane, alkene, and alcohol without memorizing it by just remembering that monkey eats peanut butter. So for those students who's watching my video for the first time, the number of carbon in organic compound are given with some prefixes. So if you're having 1, it is given the name of mate. If you're having 2, given with 8. If you're having 3, it will be prop. And if you have a 4 carbon, it is wood. And of course, this is the 4 word that the student usually have to remember: mate, 8, prop, and wood. And for these words, I have given a very short mnemonics. Monkey eats peanut butter. You can remember that. Monkey eats peanut butter. You can remember mate, 8, prop, and wood. Now, starting from the number 5 and onward, it is using our basic trigonometry. If we have a shape of 5, you would say 10. If it is 6, X. It is 7. It would be head. It is 8. It is oct. Now, by using this method, we can name all the alkane. Okay? So, to name the alkane, let us look at the board clearly. Okay. The first one for alkane would be mate. Okay. Second one would be ethane. And the third one would be propane, and on and on and on and on. Yes, end up with this with the ending of A and E because this is an alkane family. In the same manner, we can name for alkene. Now, take note, we don't have a single carbon alkene, therefore we don't have any compound here. Okay, so starting with the 2 carbon. So say, if just now we add up with ETH and A and E, now ETH and E and E. Okay, same. You can see, and on. For an example, this is and on. Now, if you know and able to do for all the alkane and alkene, you will be definitely able to do for alcohol. It is the same method again. This time, okay, what we are going to do is we are going to take the alkane, okay, and remove this E and change with OL. That's all. So if we see methane is going to be change the E, OL. If it is an ethane, write the same thing, change the E, OL. If you have a propane, change the E to OL. In the same manner, you would be able to name all of these hydrocarbon for alkane, alkene, and alcohol. So that is our first work that was given for you the last week. Now, let us continue. So, another top 3 question that was given for you is about finding molecular formula, structural formula, and displayed formula. So I hope you were able to find out these, as I'm going to share the answer for you. For those who missed my first 2 lessons in organic chemistry, I have shared the link and I would like to show to you so that you would be able to watch this lesson as well. So this is my first lesson, all of the students. My name is Einstein Pillai Sankaran. Okay, this is my first lesson. As well, I would have my second lesson. My name is Einstein Pillai Sankaran. So guys, if you are able to watch these 2 lessons and follow the 3rd lesson, it will be very helpful. So let us continue. Now, this was our 3 top questions for the last week. Okay. So molecular formula shows you the number of the atom present. Doesn't give you any information about the type of bonding. Okay. On the other hand, structural formula shows you the atoms and the bond present. And display formula shows you all the atoms and the bond present. So an example here. If we have a molecular formula, an example, This is a molecular formula. Okay, it just gives you an idea. There is 4 carbon and 10 hydrogen. Okay, now the next one, structural formula, shows you all the atom and the bond present, represented as lines. An example, so over here, we can see this formula in this way. Okay. Okay, usually carbon and hydrogen bond are simplified. Now, displayed formula would be a complete shown of atoms at every bond. So for the same compound C4H10, we draw 4 carbon and we will draw each hydrogen here. 1, 2, 3, 4, 5, and 6, 7, 8, and 9, and 10. So these are the 3 different things: molecular formula, structural formula, and displayed formula. So it is good that you know what is meaning of molecular formula, structural formula, because you'll be asked to write in the exam and draw. Okay. Now, so today's topic is about alkane. The first thing that you would like to know is alkanes are insoluble in water. Basically, they are oil. Okay, so they are all burned in air and are very flammable. Okay, so they're very easy to catch fire. Alkane also show a gradual trend in the following properties: melting point and boiling points, density, viscosity, and flammability. Okay, so this is something that we want to learn and remember. So I like to show to you how you can remember in a very short while. Okay, so we want to talk about what happened when we go down this alkane group, the melting point and boiling point. What happened for the density? What happened for the viscosity? What happened for the flammability? So guys, I want to share to you a simple way of remembering these points. Okay, I want to show to you first. So over here, we have methane. The formula is CH4. Okay, over here I have butane. The formula would be C4H10. And let's say I take another alkane, basically over here, that is octane. This is C8H18. So guys, you would be able to come out with the formula by just drawing. Of course, some of you might even memorize a general homologous formula for an alkane that is basically CnH2n plus 2. So you can remember this, it's good. If you don't remember, it is fine. So I told you, without memorizing, we can derive all of these things. So to remember about the melting point, boiling point, to remember about density, to remember about the viscosity, and to remember about the flammability, I like to share with you a method that was taught to me when I was small by my teacher. So my teacher used to draw a mouse here, okay, a mouse. a small mouse. Okay, and over here my teacher used to draw a cow. Okay, first over here my teacher used to draw a big elephant. Okay, so the idea comes, CH4 is very small, it is like a small mouse. Okay, methane is very small molecule, it's like a mouse. Butane, C4H10 is slightly bigger, it is like a cow. And C8H18, which is octane, is very big because it has 8 carbon, it is like an elephant. And you can use the same analogy as it goes down the group, the size are getting bigger. Now guys, when the size are getting bigger over here, try to remember this mouse, and cow, and elephant. What would happen for the melting point and boiling point? If you want to, let's say, cook them, you want to cook the mouse, which one would be very easy for you to cook? You will understand that mouse is very easy. In a very short while, the mouse will boil, and basically you already cook the mouse compared to this cow. If you compare with elephant, it's going to take you very long time for you to cook the elephant. So it shows you the boiling point or the melting point of the molecule is getting higher as you go down the group because the size is getting bigger. Now, number 2, the density. You also will understand, if you take these 3 animals and you want to put in the water, the first one to sink would be the elephant. You sink directly into the pool. Of course, followed by the cow and the mouse. The reason is, as the size is getting bigger, the density will increase as well. Now, number 3, viscous. It's referred to a property called viscosity, basically how fast they can move. Okay? So, you can see over here, you would know among the three animals, the one that basically have very slow movement would be elephant. Why? Because it is very big. So here, this elephant is basically, we can say, having the larger viscosity. It moves very slowly because the large size compared to the mouse. Mouse have a very low viscosity. It can move very fast. The last one, okay, if you were to make a barbecue, okay, you want to burn it and make a barbecue, you would know this is the most easy. This is a bit hard. This is going to be very tough. All right. So in the same manner, in terms of flammability, the smaller hydrocarbon usually can burn very quickly. The larger it goes, the harder it gets to burn due to the size is getting very bigger. And just for your information, the larger the hydrocarbon, it won't get burned so easily as it's also changing from gas, liquid to solid. So we can't really use them as a good fuel. So I hope you can remember my story about the mouse, cow, and elephant. It's a way of you to remember these things. Okay, let us continue. The next one. So alkane is used as a fuel. So alkane go through combustion reaction, and there are 2 ways of combustion. One is complete combustion when it has sufficient oxygen, and the other one it has incomplete combustion, doesn't have enough oxygen. So we're going to look both of the ways of writing this equation in the whiteboard here. So remember guys, in both complete and incomplete combustion, in both ways, we make or we need oxygen. Okay, we also produce water in both ways. So let me use an example for you. If we have methane, okay, methane under complete combustion, or we have incomplete combustion. Okay, so there are two ways. Number one, this is number two. So I want to show you without memorizing it again, how you can come up with this equation. So in both category, whether it is complete or incomplete, we still require oxygen. It's just the amount is different. So in a complete, we have sufficient oxygen. It is an open area. For incomplete, it is in a limited space. For example, in a small chamber or small room. So there's not sufficient oxygen. However, for both combustion to happen, you really need oxygen. So in your formula, you must include oxygen. Okay, so the difference is here. In both of them, we have one product that are same. We have another product that are different. So the same product is, we have water. Okay. So the next product, which is a bit different, is for complete combustion, we produce carbon dioxide. In an incomplete combustion, we can produce sometimes carbon monoxide, sometimes we also produce carbon. Okay, so now we have to balance this. Now there are many ways we can do this. I want to show you one of the simple ways. So we have one carbon, all right? We have 4 hydrogen, we only have 2 hydrogen, so I will put a 2 here. So now we have 4 hydrogen here and 4 hydrogen here, complete. Now, let us look for oxygen. We have 2 oxygen here and 2 oxygen here, 4. But only we have 2, so we put the 2 here. So this is the way for the first one. Now, let's say we look at for incomplete combustion. We have 1 carbon, we have 1 carbon. Okay? We have 4 hydrogen, we only have 2 hydrogen. So I'm going to put a 2 here. So now we have enough carbon and hydrogen. Now we have 2 oxygen here. We have basically 3 oxygen here. All right. So try to remember what number. If we multiply with 2, we can get 3. So some of you remember, if I were to have 1.5 multiply by 2, I get 3 oxygen. So I have 2 and 3. So is it correct? Yes, it is partially correct. However, you must remember, when we describe about the molecule must be always round number. We cannot have half molecule. Okay? It's just like we cannot have half number of participants in class. It must be either 10 students or 11 students. We cannot have 10.5 students. Doesn't make any understanding. In the same manner, when you talk about molecule must be a complete whole number. So when you have 1.5 here, we will multiply everything with 2. 1.5 multiplied by 2 is 3. Here multiply by 2 become 4, and here you have 2. So this is the way. So guys, incomplete combustion can produce carbon monoxide. Sometimes if you want to write incomplete combustion producing carbon, it is also acceptable. So same manner, we have 1 carbon, we have 1 carbon, we have 4 hydrogen, we have here 2 hydrogen, so we put 2 here. Okay, so we have 2 oxygen, we have 2 oxygen. Fine. So guys, in the same technique that I've shown to you just now, you can change and try with, let's say, ethane. Okay, you also can try with propane. butane, anything. All this would be helpful for you to understand how to write chemical equation. Now, the next one. Okay, so once you have learned about complete and incomplete combustion, the next one is methane. Methane react with chlorine in the presence of UV light as follows. So this is known as a substitution reaction. So again, I want to show you how to write the formula for this without memorizing it. Okay, and then if you have an excess chlorine, you can substitute more of this hydrogen. Okay, let us look at the whiteboard now. Okay, so we have a substitution reaction. We have a methane. So we have one halogen. An example can be chlorine. First can be bromine, iodine, anything. So this chlorine atom from this chlorine molecule will go and substitute one of the hydrogen. So we will form okay. So you can see you just remove one hydrogen, you replace one chlorine into, and you can get CH3Cl. Okay, it's a chloromethane and HCl. Of course, what you need to put the most important part here, because this only happens with the presence of UV light. So you need to mention over here UV light. So guys, you may ask, without UV light, this substitution reaction will not occur. Okay. Now, in another part, you can see that if we have more chlorine, this compound chloromethane would be again substituted with another chlorine. An example, so what happens? Same thing, it's chlorine, substitute another hydrogen. So you may ask, can it continue? Yes, it can continue until finally you substitute all this hydrogen and you produce CCl or tetrachloromethane. It can happen. So, but my idea would be, as long as you can understand this concept, you can try with any compound. Okay, you can try with ethane, propane, and butane. Now, let us continue. Okay. So, after you have learned substitution, the last one, cracking, is a process of breaking down larger hydrocarbon into smaller alkane and alkene using high temperature and catalyst. So guys, this is known as a thermal decomposition. So to remember cracking, try to remember, it's a very famous biscuit known as crackers. So we usually crack before we eat. All right. So this is my last equation I want to show you in the board today. So when we have any hydrocarbon, large hydrocarbon, an example, let's say we have octane, H18. Okay, this octane will break to become one alkene and another alkane. An example, it can become an example C2, okay, H6, all right. So what is left is we have say 6. So remember 2 plus 6 is 8. So from 18 you already taken 6, left with 12. So you may ask, can I have other combination? Yes, you can have other combination. Okay, an example is another combination for you. C3, H8. So you would have C5, H10. So all of these are possible. So you can do any combination. So this process is known as cracking. You are breaking a larger molecule of hydrocarbon into smaller chain. Okay. So guys, to do this, it is done. We require a catalyst and a very high temperature. Okay. Now, so I'm going to end my lesson for today. So I will leave our class with 3 top questions as usual. My first question, why are alkanes generally unreactive? As we can see, the only reaction it goes through is substitution, cause combustion. And for the substitution, it requires ultraviolet light. Number 2, why we are doing cracking alkane in industry? Okay, why cracking alkane in industry? And the last one, why incomplete combustion in alkane could cause danger for humans? Try to think why incomplete combustion can cause danger for humans. Okay, guys, that's all for me for today. Hope to see you again in my next lesson. Bye for now.